Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue talking about my current project of trying to code a complete dungeon crawl in 25 days. This is day 15 of the 25-day challenge. In the last video, we talked about how the program displays the area of the dungeon which the party is in, letting the player know which directions they can move in. But we haven't said anything about how the program determines what that area is going to look like. How does it determine whether there's going to be a tunnel to the north and south, etc.? Well, the algorithm for doing that is quite simple. Coding it is surprisingly complicated given how simple the algorithm is. But first, the algorithm. The starting area always has all four possible directions. Then it makes sure that it's being consistent. So for example, here there's a tunnel to the north, and that means that the area immediately to the north must have a tunnel going south. So if I go north, we can see that yes, there is a tunnel going south. And the same is true of other directions. If I went west, there'd definitely be a tunnel going east, and so on. Similarly, I can't go north here, but if I made my way to the area immediately to the north, so I might go east and then north and then west, I would find that there was no tunnel to the south. So that's the first step. Make sure it's consistent. If there's no area that determines whether there should be a tunnel in a given direction, then it just chooses randomly. There's a 1/3 chance of a wall and a 2/3 chance of it being open. So how do we program that? Well, firstly, we need a variable that keeps track of the state of each area of the dungeon, and that is the tunnels array. It should be a 3-dimensional array. It's currently a 2-dimensional array. Because this is meant to be a traditional dungeon crawl, and traditional dungeon crawls, the dungeons have multiple levels, we need, as well as an X and a Y coordinate, we also need a Z coordinate to keep track of how deep the party has gotten. We also need variables to keep track of where the party is at any given moment. And those are party_X, party_Y, and party_Z. Now you can see that they start at different values. They start at 0, 0, and 1 respectively. There's no importance to that. The player never sees the coordinates, so it doesn't matter what they are. It's just that on graphs, the center point of a graph is 0, 0, so I use 0 and 0 for X and Y, and in fantasy gaming you call the level that the party starts at level 1, not level 0. So that's why there's that difference. It doesn't have any importance. So we immediately have a problem, which is there are 4 tunnels, and each of the tunnels can be open or closed in any combination. So there's 4 bits of information for any given area, but we only have 1 slot in the tunnels array. So how do we store 4 bits of information in the one area? Well, there's a few different ways. For example, I could have gone something like this. I could have had a 4-digit number or a string in each location, and I could have said, well, the first number is whether there's a tunnel going north, the second one is east, next one's south, next one's west. And so if that was the value, that would mean there was a tunnel going north and one going west, but there wasn't one in the other 2 directions. What I did was something very similar to that, using 1, 2, 4, and 8. I decided that north had a value of 1, east had a value of 2, south a value of 4, and west a value of 8. So let's say we have a tunnel to the north and a tunnel to the west, but not a tunnel in any other direction. We just add those 2 up, and we get 9, and we can store the value 9 in the relevant slot of the tunnels array. And if you've got the numbers 1, 2, 4, and 8, there's no way to add those up and get 9 other than 8 and 1. So if I have 9, it's possible to know, that means north and west. And so that's how we store the numbers in the tunnels array, how we store 4 bits of information in one location. And that seems to be all we have time for at the moment. So I'll talk about how we access that number and read what it means and make use of it in the next video. I will leave it there for now. I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.